Hi, Assalamualaikum. Before MCO, because of the COVID-19, we have discussed the powers of sine and cosine for odd power in the real classroom. So, in this video, I continue to connect with the integration for powers of sine and cosine for even powers. Okay, in example of powers of sine and cosine odd, we use U substitution. However, to integrate the powers of sine and cosine even, we can't use U substitution. Instead, we have to use double angle identity. This formula we can get from double angle identity, which is from cos 2x equals to 1 minus 2 sine squared x, and then we make 2 sine squared x as a subject, and then we have half 1 minus cos 2x. Okay, after that, we need to move out constant half from the integration sign, and then we can integrate one by one. We still put the constant half, and we integrate 1 with respect to x, so the answer is x. Okay, after that, we integrate a cos 2x, so the answer is half sine 2x. Actually, to integrate cos 2x, we can use formula integration of cos ax dx equals to 1 over a sine ax plus c, and you can refer from chapter 1, page 11. Okay, after we integrate one by one, then we expand. So we multiply half with the x in bracket, and we multiply half with half sine 2x. So the final answer is half x minus 1 over 4 sine 2x plus c. You got it? In our first example, we discussed about the powers of sine even. Now, how to integrate the powers of cosine even? Actually, the technique is almost the same. Then we look for the complete solution. Then you can compare the solutions from example 1 and example 2. Okay, if we want to integrate cos squared x dx, we can see that the cos is even. And then we need to use double angle identity. The formula is similar to sine squared even, but in between is plus. Okay, we get this formula from double angle identity. From cos 2x equals to 2 cos squared x minus 1. Then we make cos squared x as a subject. So we have half times 1 plus cos 2x. In example 1, we have sine squared x, and in between is minus sign. Now, we have cos squared x, and in between is plus. Then we need to move out the constant half, and then we integrate with respect to x one by one. We still put half, we integrate 1, so we have x, and then in between still plus, and then we integrate cos 2x, so the answer is half sine 2x. Again, we use formula integration of cos ax dx equals to 1 over a sine ax plus c, and we refer from chapter 1, page 11. And then we expand, and you can see that the final answer is similar to example 1, but in between is plus sign, because we get from double angle identity formula, which is cos squared x equals to half 1 plus. So this one is plus sign. So that's why it will follow plus sign until the end of answer. Okay, you got it? Coming up next, example 3, integration of sine squared x cos squared x dx. So, stay tuned. Bye. Assalamualaikum.